Electrons are really important in bonds and in charge. And so we analyze what happens to electrons in reactions. One of the ways that we describe how a reaction occurs is with the term oxidation or reduction. If you look at zinc, zinc went from having a 0 charge here, see no charge is written, so it's 0, to a positive 2 charge in this reaction. We call that, that is the loss of electrons, and we call that oxidation. If I look at copper, copper went from having a 2 plus charge to, see no charge written, so it's 0, to a 0 charge. It had to have gained 2 electrons for that, and we call that reduction. So whenever you have the loss of electrons, that's oxidation, and whenever you have the gain of electrons, that's reduction. It's sometimes very confusing to students to try to keep this straight, because when you see the word reduce, you think loss, and so you do not get this order right. So I use the word Olay to keep it straight. Oxidation is loss of electrons, and of course reduction is the opposite. In redox, we call this oxidation reduction, we will call with a shorthand redox. What always happens is that electrons are basically being transferred. Something loses and something gained. They have to go hand in hand. So whenever you see a reaction in which charge is changing, then you have redox occurring. One atom is gaining electrons, reduction, and one is losing electrons, oxidation. You can't have a real reaction occur in which it is just one or the other occurring. To determine if oxidation and reduction is happening in a reaction, you look at the charge. Now, there's some reactions in which no oxidation and reduction is occurring. So what you can do is go to each atom or group of atoms and see if charge is changing. If an atom becomes more positive from the reactant to the product stage, then electrons are lost and it was oxidized. If it becomes less positive, more negative, electrons are gained and it was reduced. Here's an example. Look at this reaction. You have oxygen reacting with sodium to form sodium oxide. Let's assign charge. The charge on the oxygen, notice there's no charge on this and it's not bound to anything else, so it has to be neutral. Sodium, same thing, it's not bound to anything else and there's no charge written on it. So both of these have a 0 charge. But in this compound, oxygen has a -2 charge and sodium has a +1 charge. So now what we do is we go and connect the two to see what we have ongoing. From oxygen on the reactant side to oxygen on the product side, you have the gain of 2 electrons. So what is the gain of electrons? Well, that's reduction. From the sodium on the reactant to the sodium on the product side, you're going from 0 to +1. That's the loss of an electron. So sodium was oxidized and oxygen was reduced. Now, when you have covalent compounds, you can't do it that way because there's no charge. So let's just look at an example. If I look at methane plus oxygen burning to give you carbon dioxide and water, there's definitely changes occurring, but we can't see any charge in these molecules. There is no charge. The way we do it when it's carbon compounds and there's hydrogen and oxygen attached is we just look at the numbers of hydrogens and oxygen. If I go from this carbon here to this carbon here, you can see hydrogens were lost. Anytime hydrogens are lost, that is oxidation. When I go from here to here, I can actually see the carbon loses oxygens, gains oxygens. Well, that also is oxidation. So anytime you have the loss of hydrogen or the gain of oxygen, you have oxidation occurring there. So the carbon was oxidized. If I look at the oxygen going from here to here, you can see that the oxygen gained hydrogen. So the oxygen was reduced. Okay, so when the question is regarding redox, what you do, you look either at charge or you count the number of hydrogens and oxygens. If it's oxidation, the charge is becoming more positive. Or if you have to examine hydrogen or oxygen, the atom loses hydrogen or gains oxygen. If it's reduction, the charge is becoming less positive or more negative, whichever way you want to say. If you're examining hydrogen or oxygen, the atom loses oxygen or gains hydrogen. This is going to be a little bit, it's a lot of things to remember here, so you're going to need to practice a lot of these reactions. Go ahead and try this. Okay, the first thing you notice is that this is an ionic reaction. So even if it didn't say assign charges, you should say ionic compounds. I've got to assign charges in order to determine what's oxidized or reduced. So you assign the charges. Because there's 4 chlorides attached to this titanium, it must have a positive 4 charge. Chlorines have -1. The magnesium, because it has no charge written up here and it's not combined with anything, it's a 0. The titanium likewise is a 0. And then the magnesium here has a positive 2 charge because of where it is in the periodic table, and also because there's 2 chlorides. So here are those charges written out. You can see chloride is not changing, but the titanium is going from +4 to 0. +4 to 0 is becoming less positive, so it gained electrons. I look at the magnesium, it's going from 0 to +2. So it is losing electrons and it's oxidized. Remember, if something's oxidized, something else is reduced. So you can't ever say that both titanium and magnesium are oxidized. It must be that one is oxidized and one is reduced. So if we look at this molecule, ethanol, being changed to acetic acid, is a carbon being oxidized, reduced, or neither? Okay, if I look at ethanol, you can see it's a covalent compound. No charges involved. So I know I have to look at hydrogens and oxygens. If I look at beforehand, 2 carbons have 6 hydrogens and 1 oxygen. If I look at afterwards, 2 carbons have 4 hydrogens and 2 oxygens. What happened? Loss of hydrogen. Loss of hydrogen is oxidation. What also happened? Gain of oxygen. So that also is oxidation. So whenever it doesn't always have to be both. It can be either hydrogen or oxygen, or it can be both that you consider. Let's look at this. A protein called cytochrome C participates in ATP production. It has an iron 2 that's changed to iron 3 and then back to iron 2. So this iron goes from iron 2 to iron 3. Is this oxidation or reduction? Well, to go from 2 positive to 3 positive, there must be a loss of electrons, as shown right here. So what happened? Oxidation.